How's it going, everybody? So this is going to be a continuation of the square root method and how when we start taking the square root of negative numbers, we can get some imaginary numbers to come. Now, there is a definition that is kind of posted right here where it's kind of talking about, the imaginary unit I. And it kind of gives a little bit of background over the property itself. And the biggest idea and the biggest takeaway to understand is that when you go ahead and you have a negative inside the square root, it comes out as the letter I, okay? And you'll notice the R, the value, stays the same. Now, to put that more into practice, looking at number 1 right here, you have the negative inside that root. Well, when you take it out, like I said, it becomes I. So you have yourself I. Then you have the square root of 25. And then this right here, the square root of 25 is going to be 5. So we'd have ourselves a 5i. Okay? And so that would be our answer. Now, please keep in mind, yesterday I was talking about how when you have x squared is equal to a negative 25, this is when you would use plus or minus. But we're not taking the square root yet on both sides, which is why it's not plus or minus 5i yet, okay? So please keep that in mind. Now, we will do some examples where we will use the plus or minus. But continuing on to the next example, the 2, we have ourselves a 72. Now, conveniently though, 72 isn't going to be pretty. It's going to come out to be a decimal. And so what we need to do is use the factor tree to figure out what's going to come out of the root itself and what has to stay behind. Well, one thing we do know for certain is that the negative will come out as I, and we have 72. Now let's go ahead and look at 72 as a number and what are the multiples of it. So one that comes to mind is 2 and 36. Then I know 6 and 6, 2 and 3, 2 and 3. Now remember, what is able to leave the root is pairs. So notice how I have a pair of 2's right here, and I also have a pair of 3's. So I get to have a 2 come out and a 3 come out. Now please don't forget, this over here, this lone 2 did not have a pair, so he has to go back inside. So the way that's going to look in the end is we have ourselves a 2, and I'll put the colors too. 2, and then our 3, and then of course the 2 that was left behind has to go back inside. Now we're going to go ahead and simplify it more. Okay, 2 times 3, that's 6, and then we'll have 6i square root of 2. And that would be our answer, okay? Now let's take a look at number 3. Number 3 here, okay, we have ourselves the negative 5 times the square root of negative 9. What we're going to go ahead and do is first and foremost address the negative on the inside. That's going to come out as an I next to the 5. Now we have ourselves the square root of 9 itself. That is going to be 3. Now, what we can do here is we can combine terms here. We'll actually multiply the coefficients together is probably the better way of saying this. The negative 5 times the 3 is going to give us a negative 15i, okay? So that's kind of how we interact with negatives that are inside the square root themselves. And you kind of saw there for a split second how numbers also interact around the value of I. And so now what I'm going to do is, now that we kind of know how to deal with the negative inside the root, I'm going to show you how the complex number I interacts with itself and other numbers, okay? So let's take a look at this. So sometimes you might be adding and subtracting values of I. And the truth is, all it is think of I as like X. You combine it as if it was a like term. And you combine the other ones like terms. So for instance, the 8 and the 5, those are like terms. And so you would do 8 plus 5, okay? And then you would go ahead and combine the negative I and the 4i. And all I did was rearrange it so that way you could better see what I'm trying to communicate. That these are the like terms that are going to go together. Now, this right here is going to give myself a 8 plus 5, that's going to give me a 13. And then negative I plus 4i, that's going to give me a 3i. And so this right here, guys, is the answer to number 5, just combining like terms, just like that. Now over here, we have ourselves the same thing. What you're noticing here, though, is there's a negative on the outside of the parentheses. You have to be careful. You got to make sure that you distribute the negative, because if you don't distribute the negative, typically people get the answer wrong. You got to make sure the negative applies to each number, and it's good to go ahead and to do that ahead of schedule. So we have 13 minus 2 minus 7i plus 5i. Now all you have to do is combine the terms. Conveniently, they're already next to each other. 13 minus 2, that's going to give us an 11. Negative 7i plus a 5i, that is a minus 2i. And there you go. Also, something that you'll notice as well is that I always wrote it as a plus bi. You always write the constant first, and then you write the I second. So just something to keep in mind, that the standard form for complex numbers is your real plus your imaginary. Okay? And that's how they go ahead and write it. So this is the real. This is the imaginary. Alrighty, now, not only are they adding and subtracting the imaginary numbers, but you could also multiply them as well. We'll talk about division one of these days, but for now, let's focus on just adding, subtracting, and multiplying. Now here, this method is a method we've used before. This is the foiling method, okay? Now, the only thing that you need to really understand before we start multiplying is this concept over here, that I squared is equal to negative 1. And honestly, if you want to cut out the middleman and just have I squared equals negative 1, that's the big idea, okay? Now, if you were, now just to kind of put this in the back of your mind, if you had a I to the 4th power, that's just like saying I squared times I squared, which could be thought of as negative 1 times negative 1, and of course would equal positive 1. So the idea is, as long as you break it up into its I squareds, you can figure out what the value is going to equal. Now, that's just something I wanted to go ahead and show, so that way, like, if you encounter that one day, you'd be able to know how to handle it. Now, what you're going to go ahead and do next is you're going to go ahead and FOIL this one right here. So the idea of FOILing is we're going to do 9 times negative 4, that's negative 36. Then we're going to do 9 times the 7i, that's going to give us a 63i. Okay. Now we're going to go ahead and do negative 2i times these values. And so negative 2i times negative 4 is a positive 8i. And then I have negative 2i times 7i. Now that's going to give me a negative 14, but then I times I, just like x times x, is going to be squared. So we have I squared, because that's what I times I equals. Now you just combine like terms like we did previously with the whole, the adding and subtracting. So we have ourselves a negative 36, doesn't have any like terms, but 63i and 8i, those can combine. And so that's going to give us a 71. So I have 71i, and then my minus 14i squared. Now, we just got done saying, though, that I squared equals a negative 1. And so we can go ahead and replace it with the negative 1. And it looks something like that. Now, we can simplify that further by saying negative 1 times negative 14 is positive 14. Now, at this moment, we can see that there's like terms, the negative 36 and the 14. We could combine those and get us a negative 22. So I have negative 22 plus 71i as my official answer. Okay? So that right there would be an example of us multiplying two factors together and simplifying it down into that standard form where you have the real and then the imaginary part. Now let's take a look at this one. This is an instance where if you see something that's squared like this, what this is communicating is that you have 2x minus 3i twice. And so you would write it like this. And so what you'll notice is we have the same thing as number 7. We're going to go ahead and FOIL. So we're doing 2x times 2x. That's going to give me a 4x squared. 2x times a negative 3i. That's going to give me a negative 6xi. Now the x and the I are not going to interact with each other because they're two different things, okay? You just write them, okay, just like that, xi. Now we go ahead and do the next part, negative 3i times 2x. That's going to give me a negative 6ix. Or actually, I should probably write it like I did the other one, xi. There we go. That way you can see the like terms a little bit better. And then, of course, negative 3 times negative 3i. That's going to give me a positive 9i squared. Now let's combine some like terms. So we have our 4x squared minus 12xi. And now the I squared could be converted into the negative 1, right? And so we have 9 times negative 1. And so we have that right there, negative 9. Now, nothing else is going to combine here, though, because these are all three separate terms. I don't have another constant like with number 7. So this is where it would end here. And so that right there is another example of multiplication. Alrighty, now that we have a little bit more understanding of how to work with the i's, adding them, multiplying them, basically we know how to handle I no matter what it comes in what form. Now let's kind of go back to what we were doing yesterday, where we were solving for the value of x and using the square root method. Now, looking at this right here, we would subtract 2 on either side, and that would give us a negative 5x squared is equal to 80, okay? Now, remember, we divide on either side, and so we have ourselves a negative 16, right? Now we take the square root on both sides, just like yesterday. And remember, this negative comes out as I. And now you have the square root of 16. Well, we can do the square root of 16. That's going to be plus or minus R4. And the way we write it is we write it as plus or minus 4I. And there you go. So now you can kind of see the integration of the value of I because of that negative inside the square root. Now let's go ahead and do number 10. We're going to add 5. And so this right here is going to give me 54. So I have 54. Divide by 3 on both sides. That gives me 18. And conveniently here, we do not end up with a negative. So all we have to do here is simply take out what they have, or what can come out in a pair. So we have 2 times 9. So that's 3 and 3. So the 3's are a pair, so they can leave. So I end up with x is equal to plus or minus 3. And then the 2, the lone 2 has to go back inside. So I have plus or minus 3 square root of 2. Okay? Now let's go ahead and do number 11. Number 11 goes ahead and starts off by having us add 3 on both sides. So we add 3. So this is going to give us a 3x plus 1 squared is equal to, and that's going to be 12. We divide by 3 on both sides, and that gives me x plus 1 squared is equal to 4. And here we now go ahead and take the square root, right, on either side. And that's going to give me x plus 1 is equal to plus or minus 2. And now we go ahead and subtract 1 on either side to get x by itself. And now I have x is equal to 1 and x is equal to negative 3. So now let's go ahead and take a look at number 12, okay? Now number 12 is kind of highlight the ideas that we are doing today as well, because if we divide by 7 on either side, we're still going to end up taking the square root of that negative number. So I have x plus 2 squared is equal to negative 48. Conveniently, 7 did go into 336 48 times. Now let's take the square root on either side. Now remember, the negative comes out as I. Okay? And now what we're going to do is see, can you do the square root of 48? And honestly, you can't. It's going to come out as a decimal. So we break up 48 into its multiples. I always like to try to divide by 2. And that gives me 6 and 4. 2 and 3, 2 and 2. So I actually got some opportunities to get out some pairs. I immediately notice I've got a 2 here and a 2 here. And I also have another pair of 2s. I've got these. Now the 3 unfortunately does not have a buddy. He's going to have to go back in the root. So what we have here is a x plus 2 is equal to our, and I'll go ahead and use the color coordination. The 2, that was the ones I highlighted in red. Then this is the 2, the ones I highlighted in blue. And then of course, the lone 3 that unfortunately did not have a partner and has to go back inside. Now, the only thing to remember is this is indeed plus or minus. Now let's go ahead and just simply multiply that and go ahead and I'll go ahead and break this up into 2 steps still. So that's plus or minus 4 square root of 3. Now subtract 2 to the other side and we have ourselves a negative 2 plus or minus 4 square root of 3. And so guys, that's basically now an integration of seeing the negatives inside the roots, how we address them, how we work with them. Oh, and Mr. Farmer almost forgot his I. That would have been terrible. There we go. Now we're good. So don't forget your I, guys. Make sure it goes throughout the entire problem. So there's I, like I said, and if you guys have any more questions on the assignment, let me know. More than happy to help, and great job today, guys. Alrighty, bye.